Okay, everybody, welcome back. We are now going to write down the Lagrangian for this problem. And we also need to remember what was our intratemporal utility function. I didn't write this down. Just remember that we're going to use log consumption. We're including this theta term, Lt to the 1 plus sigma L divided by 1 plus sigma L. And we remember that sigma L is the inverse Frisch elasticity, which describes the trade-off between leisure and work. So how much the agent needs to be paid in order to give up a unit of leisure. Okay, so we need to form the Lagrangian. Change colors. I don't like this purple so much. So we're going to form the Lagrangian, and remember it's going to be an infinite sum of objective minus controls for each time with the Lagrange multipliers. So we're going to need two multipliers. We're going to need a multiplier here. We'll call it lambda. And we're going to need a multiplier here. We're going to call it q. Okay, so when s equals 0, we can write down this. So we'll have just ln ct minus theta lt 1 plus sigma l divided by 1 plus sigma l minus lambda t ct plus it minus rt kt minus wt lt minus pi t. And now we need to do our second Lagrange multiplier. So again, we're going to have minus qt kt plus 1 minus 1 minus delta kt minus 1 minus gamma over 2 it over it minus 1 minus 1 squared it. Okay, so that was our first one. Remember, this is an infinite sum, so we need to write down one of these for every s. So all of this is associated with s equals 0. And now we need to step forward, and we need to consider s equals 1. So let's have a whole nother chunk of Lagrange for s equals 1. And that's going to be the exact same equations, just with all the indices shifted, and there's also a beta. I'm going to put a beta all the way out in front here. And then we begin. ln ct plus 1 minus theta l t plus 1 plus sigma l over 1 plus sigma l minus lambda t plus 1 times ct plus 1 plus it plus 1 minus rt plus 1 kt plus 1 minus wt plus 1 lt plus 1 minus pi t plus 1. That's everything for lambda t plus 1. Now we're going to have qt plus 1, kt plus 2, minus 1 minus delta kt plus 1, minus 1 minus gamma over 2, it plus 1 over it, minus 1 squared, it plus 1. Okay. And just to be very, very, very precise, I will also remind us that this is all expectation. So we're going to have beta times the expectation at t. Okay, and that all goes in an expectation sign. And then in principle, we have dot, 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 because we're also going to have s equals 2, s equals 3, and so on. But you should be able to see that there won't be any terms that we care about. We only care about ct, kt plus 1, lt, and it. And we care about this s equals 1 case because we can see that there's some kt plus 1 here, and there's some it here. There's also a kt plus 1 here. So we care about this one. We see some control variables in this one. But if you step this again, if we look at s equals 2, this kt plus 1 would be kt plus 2. We don't care about kt plus 2. And this it would be it plus 1. We don't care about it plus 1. So we can stop here. Okay, so this is a Lagrangian. And all we need to do now is take derivatives of this. And it looks big and messy, and it is big and messy, but you just have to take it step by step. So I propose that you solve for the three easier ones, which will be CT, KT plus 1, and LT. And then I will do that with you in the next video. And then to wrap it up, we'll look at IT. So I'll see you there.